Alright, so for today's notes, we've got identifying inverses and then solving for inverses. So first we're going to identify inverses using composition. So there are multiple ways to identify an inverse. We can do it using a graph, or if we're just given the functions in like a written form, then we can use composition. So if f of g of x equals x and g of f of x equals x, then the two functions are inverses. So we're going to determine by composition whether each of these pairs are inverses. So for this first one, I need to find f of g of x. So that means I'm going to plug g of x into f. So for my f function, I have 3x. So I'm going to write 3. Then instead of writing an x, I'm going to write the function g of x, which is 1/3 of x. Remember, when I'm looking at fractions, 1/3 x is the same thing as x over 3, which is the same thing as x divided by 3. The opposite of division is multiplication. So if I've got 3 times 1/3, those two will cancel. 3 times 1/3 is 1. So we've got x. We're checking, does f of g of x equal x? And it does. So now we need to check, does g of f of x equal x? So we're going to plug in the function f of x into the function g. So my function g is 1/3 times x, and instead of writing an x, we're going to write the function f of x, so 3x. Again, we have 1/3 times 3. 1/3 times 3 we saw is 1. So we have x. We got 1x, which we write as x. So they both equal x, so these are inverses. We'll do the same thing with number 2. It's just going to be a little trickier because we have more than just one term. So we're doing the same process where we're taking f of g of x. So we're looking at our function f of x, and everywhere we see an x, we're replacing it with this whole function. So instead of 3 times x, we have 3 times 1/3 x plus 1. Then don't forget this minus 1 on the end. Now we're going to find what this equals. So we're distributing the 3. 3 times 1/3 we saw in the problem before is 1. So it's just x. 3 times 1 is 3 minus 1 on the end. Oops. X. 3 minus 1 is 2. Does this equal x? No. I needed to say equals x. X plus 2 is not the same thing as x. So already I can say these are not inverses. We need both f of g of x and g of f of x to equal x. And if one of them does not work, they are not inverses. Then let's try with number 3. Same process. Start with f of g of x. We're going to plug in g of x into my function f of x. So f of x is 3 times x. Instead of x, I'm writing the function g of x plus 1/3. And then don't forget that minus 1 on the end there. Distributing this 3. So we've got 3 times 1/3 we said was 1. 3 times 1/3 is 1. And then we've got that minus 1. So x plus 1 minus 1 1 minus 1 is 0, so we've got x plus 0, which we know we don't need. So we say x, f of g of x equals x. So it's working with the first one. Then we'll check with the second one. So g of f of x. So now I'm starting with the function g, and instead of writing x, I'm going to write this whole function here. So 3x minus 1, and then plus 1/3 on the end. I'm distributing a third. So 1/3 times 3x is going to be 1x. 1/3 times a negative 1 is a negative 1/3. And then don't forget that plus 1/3 on the end there. Then I have x minus 1/3 plus 1/3. A negative 1/3 plus 1/3 is going to be 0. They cancel each other out. We don't need that. So we would say x. We've got equals x equals x. So these two are inverses. So that's how you check whether or not they are inverses. And now we're going to solve for inverses. So there are two steps for solving for the inverse of a function. We're going to switch x and y and then solve for y the way we normally would. This is one of my favorite things to do. So we're going to find the inverse of f. So looking at number 1, we have 4x plus 7. My first step is to switch x and y. So whenever I say f of x equals, it's the same thing as saying y equals. So 4x plus 7. So now it's going to say x equals 4y plus 7. So we see that we switched the x and the y. And then step 2, solve for y. So I'm going to say x equals 4y plus 7. I want to get this y by itself. So minus 7 on both sides. I have x minus 7 equals 4y. I still need to get this y by itself, so I'll divide it out. And that gives me x over 4, or 1/4 x, minus 7 over 4 equals y. And when we write an inverse function, because I already got this y isolated, we say the inverse of f of x is equal to, and then everything that y equals. So x over 4 minus 7/4. And then that would be my final answer. So we just switch the x and the y, and then we solve for y. So let's do number 2. Same two steps. We're going to switch the x and the y. So I'm going to rewrite this as y equals x squared over 3. And then step 1 is to switch those. So x equals y squared over 3. And I need to solve for y. So I need to get this y that's on top all the way to this side. So the first thing I want to do is get rid of this 3. So I'm going to multiply both sides by 3. So the opposite of dividing by 3 is multiplying by 3. I've got 3x equals y squared, because these two will cancel. And I still need to get y by itself. So the opposite of squaring something is square rooting something. So the square root of 3x is equal to y. I've got y by itself, so I'll rewrite that as the inverse of, so inverse of f of x is equal to the square root of 3x. Then on number 3, we got the same thing, but now it says g of x. G of x is the same thing as saying f of x is the same thing as saying y. So any function of x is the same thing as saying y equals. So y equals 2 square root of x. I'm going to switch my x and my y now. So x equals 2 square root of y. I need to get this y by itself. So the first thing I'm going to do is divide by a 2. So we see that this 2 is multiplying by the square root of y. So we can say 2 times that. To get rid of it, I have to divide by it. So x over 2 is equal to the square root of y. To get rid of a square root, I have to do the opposite and square. Whatever I do on the left, I got to do on the right. When I square a fraction, it's the same thing as saying x over 2 times itself. So we got to make sure that we square both the top and the bottom. So I'm going to square the top, x squared, square the bottom, 2 squared is 4, and that equals y. I have this y isolated, so I would say the inverse of g, because that was my original function, g, and that equals x squared over 4. Number 4, same process. We're going to switch our x and our y's. So first I'm going to rewrite this original function with a y. And then I'll switch it over here. So x equals 2/3 y minus 6. I want to get this y by itself. So first thing I'm going to do is get rid of that constant by adding 6 to both sides. X plus 6 equals 2/3 y. I still need to get y by itself. So in order to get rid of a fraction that's multiplying, I will multiply by the reciprocal. Here, I see that I've got 2 terms multiplying by this, so I do have to distribute. So I get 3/2 x, and then I have 6 times 3/2, so half of 6 multiplied by 3, 9. So 3 over 2x plus 9 is equal to y. And my original function was g, so the inverse of g is equal to 3 over 2x plus 9. So that was finding the inverse. We did determining whether they are inverses or not first. And then we have this assignment. It's 11 questions, so I'm going to ask that you guys do numbers 3, 6, 9, and 11. So for this assignment, sorry, the tablet's not responding. For this assignment, you're only doing numbers 3, 6, 9, and 11. And take a picture and then post it on Canvas.